So hi guys, today I'm going to summarize the chapter 8 subnetting IP networks. Um, so subnetting IP networks. Designing, implementing, and managing an effective IP addressing plan. So it ensures that network can cooperate effectively and efficiently. So this is especially true as the number of host connection to a network increases. So, understanding the hierarchical structure of an IP address and how to modify the hierarchical in order to more efficiently meet routing requirements um, is an so meet routing requirement. So it is an important part of planning an IP addressing scheme. So in the original IPv4, there are two levels of hierarchical. So a network and a host. So these two levels of addressing allows for basic network groupings and facilitate a network packets to a destination network. So a router forwards packet based on the network portion of an IP address. So when the network is located, the host portion of the address allows the identification of the destination devices. So other devices. So for the other devices, um, in an Ethernet LAN, devices use broadcast to locate. So the other devices, um, it is a device uses address resolution protocol (ARP) or address resolution protocol, or ARP, which sends layer which sends layer to broadcast to a known IPv4 address on the local network to discover the associated MAC address. So the other one for the device used to so the other one is the services. So a host typically require its IPv4 address. So it address configuration. So using the dynamic host. So dynamic host configuration protocol, which is the DHCP. So which send broadcast on the local network to locate a DHCP server. So there are two considerations when planning the subnets. So the first one is the number of host addresses required for each network, and the second one is the number of individual subnets needed. So for the number of hosts required for each network, so the number of host address required in the largest subnet will determine how many bits must be left in the host portion. So, so if more host addresses are needed, then more host bits are required. So it's resulting in fewer subnets. So, um, so, so for the subnet based on organizational structure. So it is the corporate network. So you can see in this like cloud something. So it has a human resources, the sales, executive management, research and development, engineers, and technical supports. So that's the subnet based on organizational structure. So sometimes a certain numbers of subnet is required with less emphasis on the number of host addresses per subnet. So this may be the case if an organization chooses to separate their network traffic based on internal structure or the department set up. So as shown in this figure, the subnet based on organizational structure. So the next one is um, planning IP address assignment. So planning IP address assignment. So we have so yeah planning IP address assignment. We have the student LAN or the um, student LAN, faculty LAN, and the admin LAN. So as it said in here, so planning requires decision on each subnet in terms of size. So the number of hosts per subnet um, and how host addresses will be assigned. So as you can see, so as shown in this figure, the allocation of network layer address space within the corporate network needs to be well designed. So addressing assignment should not be random. So in planning network subnets, it requires examination of both the network of both the needs of an organization's network usage and how the subnet will be structured. So performing a network requirements study in the starting point. So this means looking at the entire network and determining the main section of the network and how they will be segmented. So there are three primary consideration for planning. So primary consideration when planning address allocations. So we have here the prevent duplication of addresses, provide and control access, monitor security and performance. So it's all in the planning address allocation. So so there that's are the three primary consideration for planning allocations, address allocation. So um as it said, preventing the duplication of address refers to the fact that each host in the internetwork must have a unique address without proper planning and documentation. And an address could be assigned to more than one host, resulting in access issues for both hosts. And the other one is providing and controlling access. So it refers to the fact that some hosts, such as servers, providing resources to internal hosts as well as to external hosts. So layer 3 address assigned to a server can be used to control access to that server if, however, the address is randomly assigned and not well documented. So controlling access is more difficult. So for the other one is monitoring security and performance of hosts means network traffic is examined for source IP address that are regenerating or receiving excessive packets. So if there is a proper planning and documentation of a network addressing problematic network devices should easily be found. So there are different types of devices that requires addresses including um, end, end user clients, servers and peripherals, servers that are accessible from the internet, intermediary devices, and the gateway. So the end user client. So most networks allocate addresses dynamically using dynamic host configuration protocol or the DHCP. So this reduces the burden on network support staff and virtually eliminates entry errors. So as well, addresses are only leased for a period of time. So changing the subnetting scheme means that the DHCP server needs to be reconfigured. So and the clients must renew their IP addresses. So IPv6 clients can obtain address information using DHCPv6 or the SLAAC. For the server and for referral, so this should have a predictable static IP address. So this should have a predictable static IP address. So use a consistent numbering system for this device for the server and peripheral. So in server and peripheral. So server that are accessible from the internet. So in many network, server must be made available to remote users. In most cases, these servers are assigned private addresses internally, and the router or the firewall parameter of the network must be configured to translate the internal address into a public address. So for the intermediary devices, these devices are assigned address for network management, monitoring and security. Because we must know how to communicate with intermediary devices, they should have predictable, statically assigned addresses. For the gateway, routers and firewall devices have an IP address, assigned to each interface, which serves as the gateway for the host in that network. So typically, the router's interface uses either the lowest or the highest address in the network. Global routing prefix. This is a prefix or network version of the address. So that is assigned by the provider. So typically, um, regional internet, um, regional internet registers or RIRs assigned a 48 global routing prefix to ISPs and the customer. The other one is the subnet ID. So, used by an organization to identify subnet within its site. The other one is the interface ID. So this is the equivalent to the host portion of an IPv4 address. So the term interface ID it is used to is the term interface ID is used because a single host may have multiple interfaces, each having one or more IPv6 addresses. So um, so the IPv6 subnetting requires a different approach than the IPv4 addressing. Uh, sub, the IPv6 subnetting requires a different approach than IPv4 subnetting. So the same reason for subnetting IPv4 address space in order to manage network traffic also to apply to IPv6. So due to the large number of IPv6 addresses, so there's no longer the concern for conserving addresses. So um, IPv4 subnetting is not only about limiting broadcast domain, but it's also about managing address scarcity. So determining the subnet mask and the use of BLSM is done to help conserve IPv4 addresses. So, so, so the process of segmenting a network by dividing it into a multiple smaller network spaces is called subnetting. So, every network address have a valid range of host addresses. So all devices attached to the same network will have an IPv4 host address for that network. So and a common subnet mask or network prefix. So traffic can be forwarded between hosts directly if they are on the same subnet. So traffic cannot be forwarded between subnet without the use of routers. So to determine if traffic is a local or remote, the router uses the subnet mask. So the prefix and the subnet mask are different ways of presenting the same thing. So the network portion of an IP address. So um, IPv6 subnetting requires a different approach than IPv4 subnetting. So, an IPv6 address space is not subnetted to conserve addresses. So, rather, it is subnetted to support a hierarchical, so local design of the network. So, while IPv4 subnetting is about managing address scarcity. So IPv6 subnetting is about building a addressing hierarchical based on the number of routers and the network they support. So that's all for the chapter 8 entitled Subnetting IP Network. So that's all for the summary of the chapter 8. So I hope you uh, learn in this chapter and from what I say. Um so again so thank you guys for watching.